Hi everyone! In this video, we'll take a look at how to deal with significant figures, or sig figs, following calculations of logs and anti-logs. Having to keep track of sig figs is one of those things that can seem like busy work, but when we take measurements or use them in calculations, it is really important for us to retain the precision of those measurements. In other words, we don't want to misrepresent the precision or reproducibility of our measured values or the calculated results. Now, while this video focuses on keeping track of sig figs during calculations, we can't do this unless we understand how to count sig figs and how to identify number of places in a measured value. We'll have to do both for logs and anti-logs. Here's a brief review of the rules. Exact numbers never count when they're part of any calculation. We just ignore them. When we're counting how many sig figs we have within a measured value, leading zeros never count. And trailing zeros only count if there's a decimal point shown. It's the zeros where most mistakes are made, so it is worth remembering how to deal with both types of zeros. And finally, all other numbers count. If we have to determine places, we assess which digits are significant in that value and locate the one that is furthest to the right. Then label that position. You'll see here that I will count decimal places when the sig fig is to the right of the decimal point. For calculations involving logs, either log base 10, log, or natural log, ln, the number of sig figs in the value becomes the number of decimal places in the result. We have to make a switch. Our strategy is to count the sig figs in the value, then round the calculated result to that number of decimal places. For example, if there were 2 sig figs in the value, the result will have 2 decimal places. For calculations involving anti-logs, either log base 10, 10 to the x, or natural log, e to the x, the number of decimal places in the value becomes the number of sig figs in the result. We have to make a switch here as well. Our strategy is to count the decimal places in the value, then round the calculated result to that number of sig figs. If there were 3 decimal places in the value, for example, the result will have 3 sig figs. If you run into a situation where the value has no decimal places, then round the final result to 1 sig fig. With logs and anti-logs, deliberately remind yourself that you have to switch between sig figs and decimal places in one direction or the other. That way, you'll be less likely to fall into the trap, which is just to count sig figs. In our first example, we will round this calculation to the proper number of sig figs. And so we're taking the natural log of 1.83 times 10 to the negative 4. We'll note the number of sig figs. We have 3 sig figs in our value. 3 sig figs in our value means that we'll round the result to 3 decimal places. Doing the math, taking the natural log of 1.83 times 10 to the negative 4, make sure you push the ln key, rounded to 3 decimal places gives us negative 8.606. Our next example involves an anti-log calculation, log base 10. So this is where we'll use our 10 to the x key, which is typically a second function of the log key. We'll first note the sig figs and what we need to do with them, and then we'll do the calculation. Because this is an anti-log, we're going to start by noting the number of decimal places. The 2 is our final significant figure, and this is 2 decimal places in this value. When we do the calculation, we need to round our result to 2 sig figs. So just like the last example, we're making a switch between decimal places and sig figs. So doing the math, we have a negative 2.62 we're going to take the antilog of that number. Rounding to 2 sig figs gives us 2.4 times 10 to the negative 3.